So again, my name is Cody Yarklin. I'm technical marketing representing Consul. You can see a little bit of facts about me. I'm not going to dive into everything on this slide. It's really easy to get a hold of me on Twitter. If you have questions about anything that I talk about during this presentation, I'm happy to answer them. Feel free to ping me. You can see some of my rambling on the HashiCorp blog as well as my personal blog. But the most important thing that I want to call out is that I focus more on doing demos and trying to keep slideware at a minimum. We've got a couple of slides that we got to get through around what HashiCorp Consul Service on Azure is and kind of the problems it solves. But then we're going to get pretty quickly into some demos and show some really interesting ways that we can use HCS. So let's talk a little bit about where we're going to end up, or where we're going to go through in this demo. We're going to talk a little bit about what HashiCorp Consul Service on Azure is, like at its core as far as the product goes. We're going to talk a little bit about how we get it deployed through the Azure Marketplace. From there, we're going to go ahead and bring an Azure Kubernetes cluster into that HCS cluster. We are then going to talk about how we deploy applications and have them available inside of the platform. And then finally, we're going to jump into a little bit of a secret part of the demo that we're going to hope doesn't break. One of the things I want to call out, and Peter hit on this right before he transitioned over to me, all the stuff I'm covering here is available in our Learn Guides, maybe not specifically for HashiCorp Consul Service yet, but one of the big benefits of Consul is being a consistent networking platform. And part of that big aspect of being consistent is that the same functionality exists between any platform that you deploy Consul on. So you can see these Learn Guides, go through and learn how to actually configure the stuff I'm going to show you in here. This is where we're going to end up. Apologies for the little bit of blurriness on the image there. We're going to end up with our HashiCorp Consul Service. We're going to end up with a AKS cluster deployed, an Azure virtual machine, virtual net also, and we're going to pair all these together and we're going to have some applications talking between them. First up though, what is HCS, HashiCorp Consul Service? This is a managed Consul offering. What that means is that we take care of the underlying infrastructure. Instead of you having to deploy, scale, make sure everything's running, we take care of all of that and make sure that the cluster itself is up and running and the platform itself is taken care of. So you can get back to actually operating, doing service mesh, service discovery, all of these things that you normally do with Consul. You can focus on the actual operations of it instead of focusing on how to deploy it and how to maintain it. As far as Consul goes overall, it's a multi-platform tool. We really stress that this is something that you should be able to bring in existing infrastructure into, as well as that next generation stuff inside of Kubernetes. We're really about the journey. It sounds kind of funny to say it that way, but we care a lot about our operators being able to work with infrastructure they already have and workflows that they've already established. You shouldn't have to adopt a service mesh and move all of your workloads into Kubernetes to be successful, right? You should be able to bring existing workloads into that and get some of those benefits, even if you aren't doing the service mesh, even if you're doing things like Eric talked about earlier around load balancing with F5 as an example. One of the cool things about HCS, because it's a managed platform, we've set it up to be secured by default, which means that encryption's turned on. We're setting this up to be a really secure platform. And again, beyond that, we bring in more than just the service mesh aspects with things like discovery and health and making sure that you can actually take advantage of things that don't necessarily require like a microservices approach. So that was it. That was the slideware. We're going to jump into demo time. So I'm going to switch over into the Azure console. I want to touch first on how you actually get a HCS cluster in your hands. First off, we're running a private beta. You can sign up for it. And once your account is whitelisted, you can come into the Azure Marketplace and just type in Consul, and you'll see the HashiCorp Consul Service on Azure preview show up. We can go in, we can do create, and we can start to fill out our different details from our resource groups. So I have my existing resource group in here. I'll give it a simple name, Consul Adoption Day. And after we fill in this information, we can actually have a Consul cluster in hand and ready to actually function. So it takes a little while to provision. So fortunately, I already have one provision that we can work with. So we can see this here. This Consul cluster is taking over from a couple of previous demos that I've done and recorded on HCS. So it's fairly set up and it's got a couple of things in it already. It doesn't have the AKS clusters in play because we're going to show setting that up live. But what it does have is several VMs already in place. We've got services actually registered. So we hit our nodes. We can see I have a ton of VMs deployed from inside of my Azure environment. And those are reflected in my resource group here. So if we dive into Azure, we can see all those nodes exist in both environments. And then from an actual services perspective, we got the applications actually registered. If we go into our front end application, we can see that is running on a virtual machine. And what we have configured here is an actual service mesh between these virtual machine objects. Now, that's not the point of this demo. The point of this demo is to dive into bringing AKS into the fold. But I wanted to touch on, this is not unlike most customer environments. We've already got virtual machines in place. We're looking to move to Kubernetes and bring Kubernetes in as more of like a first-class citizen inside of our infrastructure, inside of our deployments. In this case, I've got my mesh established. I've got VMs talking. I've got the application up and running over here. Very simple application that I threw together for showing demos like this. We can see that it's a 3-tier application. It's got a front end, an API, and a database. If I hit this tab, we can see I'm on the VM-based database. Right. So now we're going to go ahead and look at how we can start to get this fired off with HCS. Fortunately, Jono and Nicole did a great job of going through and talking about how we use things like Consul Helm to deploy out Consul onto infrastructure in Kubernetes. I'm going to touch on a couple of slight differences. In this case, because Consul is already operating as a server cluster, we just need to join our AKS cluster as agents. So if I do a kube control, get nodes, we can see my existing AKS cluster in play. Now, this one is set up right now to use what we call, or not we call, what Azure or Microsoft calls the Azure CNI. So what that means is that every pod that deploys inside of Kubernetes gets its own IP address from the actual subnet that it's been assigned to, which means we have routability directly in as long as we peer the VNets. And you would have seen that in the diagram I showed earlier where I highlighted showing the different VNet peerings that exist between those environments. So in this case, the AKS cluster is already deployed and peered up to the HCS VNet, which means that we have communication between. If we take a look in this directory, there's a couple of things in here. I have a script in here that's generate helm config. This was written by one of our really great engineers who focuses a lot on the Kubernetes platform, Irina Shistova. She's actually on here for Q&A, so you can bug her with questions about it. I'll show a quick peek at what the script actually does. This script goes in over the Azure API and as well as the Consul API and pulls out the different components that are needed to join nodes to that cluster. So we pull out things like the certificate, we pull out things like the gossip key. All of these things are how we ensure that a cluster is safe and secure. So we bring these in and we add these to whatever platform we're going to bring in. So in the case of the virtual machines, I added those as part of the actual configuration for Consul to join into the cluster. We also create out our configuration file. I had a slight modification to this for my use case. So what I'll do is I will go ahead and cat out that configuration file and we can step through a little bit about what's going on in here. We're connecting into my Azure data center. We've got our gossip key, which is part of our encryption, right? It's how we encrypt the traffic between actual server nodes and the agent nodes. We've got a specific TLS settings in place, which use the CA cert that we pull out thanks to Irina's script. We have a couple of steps around what nodes we're going to join or what actual environment we're going to join. So this is the internal Azure IP or internal Azure address for our Consul cluster. And we can see that we're joining it as a client. We're setting it to inject, connect. Jono touched on this in his presentation. This is how we make those sidecars pop up. We have Envoy run alongside the workloads. So this actually sets that up to inject that sidecar into every pod that deploys. And then we have some sync catalog set up true to really just mostly just show that we're actually bringing the service catalog into Consul. So like both Jono and Nicole did, I'm going to use Helm to install. I'm going to do Helm install. I'm actually not going to use that one. I'm going to use this. So this is going to fire off our deployment. We'll give it a couple seconds to get started. Cube, oops, typing's hard. Git pods A, and we'll do a little follow action. Oops, sorry, not follow, watch. Now that came up really fast because I was testing this already. So this wasn't there before. Should have shown that already, but it wasn't there before. It is now. If we switch back into our console, we can see we've got a couple new agents in place. These are our AKS agents that live inside of that cluster. So this cluster is up and running now. It's joined to Consul. So it is now that it's about halfway to the end state of that diagram I showed previously. At this point, we've joined AKS. It's part of the service mesh. So workloads that deploy are now going to have that sidecar injected, and the other things inside of our service mesh can automatically talk, which means that if we look at the services view, workloads that we deploy in Nomad can talk into that service mesh. Workloads we deploy as VMs can talk into that service mesh. These are part of what we like to call a global service mesh. These are multi-platform runtimes that are able to talk amongst each other over those Envoy proxies. Just to touch real quick on intentions, John touched on this already. I have a default deny in place. I've got some pre-existing rules in place to support my connectivity into the environment. And we're going to go ahead and deploy our application now. Before we do that, we'll take a quick look at the actual configuration. Jono, again, did a great job of stepping through this. I want to touch on a few specific things in my configuration just so we can touch on why they're there. On each of my pods, I have connect inject true. This is enforcing that we're going to inject connect every time. I've got a couple of annotations around the connectivity we expect. So I've got inject true. I'm setting a service meta version of V2. Remember this is important for later. So just keep that in mind. I'm not going to dive into what that is yet. I'm setting the service port for HTTP. And then I'm also configuring some upstream connectivity. So I'm saying that this pod can talk to the database, and this pod can talk out to the front end if I want it to. And then again, same thing goes for my front end, setting it up so that it can have connect inject true, what port it's operating on, what actual upstream it's going to connect to. So this is going to connect to our API service. And again, keep in mind this actual V2 for the service meta version. This is going to be important in a little bit. So let's go ahead and do a Q control, apply F for our demo application. And we'll see that start to spin off. And instead of watching the pods this time, we're going to watch for the load balancer to kick in. So it's going to take a little while. Azure takes a little bit to spin up its load balancer. But if we switch back, wow, that actually happened a lot faster than expected. If we switch back into services, we can see it coming to life. Now, I did something very specific in here because I was kind of on a time constrained demo. What I did was I set up this application to register into my existing service definitions. So now if we go into front end, we can see we have two different definitions of what front end is at this point. We've got the front end VM that I've named VM so we would know the difference. But then we've also got app front end, which is living inside of that AKS cluster. So these are two different instantiations of that app front end. And that applies as well to, just to be transparent, the API tier as well. I intentionally didn't do this with the database because I wanted to be able to show kind of a separate database. It would be very easy for me to combine those as well and do the same kind of flow with that. It looks a little kludgy in this. It was intentional to be separated out. All right, so let's take a look now at that load balancer and see if we actually have connectivity into it. There we go. So we can see this looks a little bit different. We're not going to wait for it. I'm actually connected really fast. This is a little bit of a cleaner interface, right? It's a little lighter. We've got the color logos. Things look good. And right now, what we're doing is we have two different applications inside of our service mesh communicating independently of each other. That somewhat solves the demo that I wanted to show, right? We're in here, we have our service mesh in place, applications are running, things are good. It'd be pretty trivial for us to flip this around and point the front end back at the API tier that lives inside of Kubernetes, or have the front end that's on a VM point at the API tier in Kubernetes, or reverse that and have the front end that's in Kubernetes point at the API tier. It's a pretty trivial thing since we're using the Azure CNI, we have routability, we peered our VNets. Like, that's an easy thing to solve, but that's not really the real good stuff here. I'm going to touch on why I said that in just a moment. Something I want to touch on from a security perspective really quick is why we group these services together and why we use intentions. If you think about the traditional firewall use case, we're used to explicitly defining service to service connectivity over IP and port, right? So .1 can talk to .5, .2 can talk to .6. We're used to that. And if you think about that model of what we're doing here, because we have our VM cluster, and then we also have our AKS cluster, in a traditional networking environment, we would expect to need firewall rules that span for every permeation of that configuration, right? So we look at Can the front end talk to the API tier in VM and in Kubernetes? Can the API tier talk to the front end in Kubernetes as well as VM? This turns into a massive firewall sprawl. What we end up doing with bringing them into the same service and taking the intentions approach is dramatically reducing the amount of firewall rules that are in play here. And we start to move into a true service to service communication. So when we look at intentions, front end is defined here. And if we look at our services and we look at front end has those two things grouped together, right? So now we're saying anything that lives inside of this service can talk to anything inside of this other service. And this gives us mass scalability, right? We're not worried about these individual rules that exist for individual services or individual IP to IP communication. We're taking this up a level and saying, you have an application and you expect connectivity to a remote point. Let's allow that connectivity as long as it's consistently defined. So every time we add things to this front end service definition, that intention is going to automatically bring it in and allow it to be part of that communication path. So we've got our communications kind of established here, but I want to get back to our previous talk around what I was saying around like it'd be trivial to move applications and services around to communicate between the two, but that's not really like the heart of the use case that people care about. What people care about, and this is like the secret part of the demo that I hinted at earlier, what people care about is migration. People care about how I can take systems running in legacy VMs or traditional VMs. Legacy gets kind of a bad connotation to it. I don't think legacy is a bad thing necessarily. It's just the thing you had before. How do I take workloads that live in that environment and be able to migrate them into a Kubernetes environment? And how can I quickly switch those back and forth? How can I do things like canary testing, where I allow 10% of traffic to go into that cluster or bump that up to 50% and then eventually fail it completely over? And we can do this by bringing in, since we're operating in a global mesh and we have these platforms all communicating over the same mesh, the same Envoy proxy, so on and so forth, we can use something called layer 7 routing to allow us to do this trick. It's not really a trick so much as a capability. So real quick, I'm going to head into our console.io website. I'm going to hit our docs, and I'm going to hit this connect section here. And if you look in layer 7 traffic management, you've got a ton of documentation here on how to configure this. What I would say is hit the learn guides. The learn guides have a really, really good L7 like training around how to actually consume this capability. What we're going to do is we're going to show live how we can start to flip this service from running inside of VMs and having it reach our destination inside of VMs to actually reaching inside of Kubernetes. And we'll do some tricks along the way to flip that back and forth and show how we can change this around. So in order to do this, we have to be a little bit aware of the architecture we're working with here. We have our Kubernetes environment here, and we have our virtual machine environment here. We know that's running on the VMs. So let's go ahead and switch into command line, and we're going to start to make a few changes. Now I'm on a VM here that's aptly titled HCS client VMs or client 04. This is an Nginx server. If I'm honest, you know, to throw shout out to Eric in the background from F5. This is just an Nginx server, right? We are proxying communication into our service mesh and allowing communication between points. And what we're going to do is we're going to start to load up some of these policies. So if I do an ls here and I cat out some of these files, you can see we're defining aspects of our service defaults, our service resolvers, and finally our service splitters. So our service defaults tell console what type of service this is. In this case, we know our front end is an HTTP service. So what we're going to do is we're going to write the configuration. This can be done via API as well. This can be done via a number of different ways. I'm doing it from the command line for a reason. We're going to do console config write. And we're going to step through and do each of these. And then I'll back out and explain what's going on here. Make sure I backed out one of these changes. I did, cool. That would have been embarrassing. All right, so let's start from the top. I talked a little bit about what this is. This is defining out that our front end is an HTTP service. By default, things come in as TCP services. We're telling Envoy that this is an HTTP service, so we can do layer 7 routing against it. If I now cat2, I told you earlier to remember that v1 thing and that v2 thing inside of the Kubernetes manifest. What I've done here is I've set up a service resolver for my front end service to say that I have two versions of this service that are in play. look at the version meta tag inside of that, inside of each of those individual registered services, and give them a label, right? So in this case, V1 maps to version V1, V2 maps to version V2. Pretty straightforward. And the real magic happens in step 3, where we say, we're gonna actually split this traffic between environments, right? We're gonna say, in this case, all the weight goes to service 1, none of it's going to service 2 at this point. So now, if I go into my application, it's going to stay going to VM because VM is the V1 is the VM environment. So there's no real change to the routability of this at this point. What's really clean is if we go into our service now and we hit that front end service, we can hit this routing tab and we can see a visual representation on how we're splitting this traffic out. And there's a lot of work going in to improve the visibility in here. I can't really dive into what that is, but there is definitely some work going into how we see this and that you should stay tuned for. But you can see I have it set for 100% of the traffic to go to that V1 front end. Let's switch this now. Now, typically in a longer demo, if I had more time, we do this Canary style and we'd send a very small amount of traffic to the V2 and monitor to make sure things were good. But it's a Wednesday, so we're gonna go YOLO and we're just gonna change it all. All right, so we're gonna vim into 3, which is our service splitter, right? So we're splitting services. And we're gonna go ahead and flip this from 100 to 0, and we'll go 100 there. We're gonna write this again. So now if we head back into console, I don't think we need to refresh, but I don't want to be embarrassed by it not showing up right, so I'm going to refresh anyways. We're now sending all of our traffic down to the V2 service. And if we hit this, we can see that front end is now pointed at Kubernetes. So we've effectively migrated in a very short and kind of cheeky way. We've migrated the way the service routes from being one hitting the VMs to now routing into the Kubernetes cluster. That's your VM migration, VM to Kubernetes migration. Obviously, there's a lot of app work. I don't want to trivialize that enterprises are still figuring out how we're going to take these monstrous previous applications and move them into the model. But assuming you've solved that, this is a really simple way to transparently move this into that Kubernetes environment. So we've done that now. We've moved to the front end. But what about the API tier? And if we go in here, we're still on the VM-based database, right? So we're still using the VM API tier, which means that the way this is routing is Kubernetes is going out and hitting it, looking at console and saying, hey, where can I send this traffic? I'm going to send this traffic to our VM API tier, which is, just for the sake of conversation, it's HCS client 02. But now let's do the same thing for the API tier, because as we're breaking this into a microservices approach, you know, Peter is hosting this call and Jono and Nicole are also helping out. I might own the front end. Peter might own the API tier and might be doing all of the dev work there. And Jono and Nicole might split database duties, right? So each one of these could be broken up in that way. So I'm going to break it up in the same way when I look at how I split up these services inside of my routing. So let's go in and add this configuration in for the API tier as well. So just to do the magic show trick, if I go and look at my API service, I look at routing, I have no splitters set up, I have nothing special in here. This is all default at this point. So let's go back in and let's do console config write 4, 5, and 6. And just to, again, show all the details. Same thing we did before, just with an API service instead of a front end. Not going to dive into how it's actually working again, but I actually didn't switch back this one. So before you all get to see that, I'm going to fix that to go back to what it should have been at the start of this demo. So I'll reconfigure that one. So let's switch back in. And we can see this is updated with our new splitter. Everything's going to V1. V1 is the VM. V2 is the API inside of Kubernetes. So if I go in here and look now and I refresh, we're still running on the exact way we were running before, right? Our API connectivity locks in immediately. Our database takes a few minutes to pick up, but it does eventually. We've got our pretty logos, things are good. Let's go ahead and flip this now, just like we did before, but instead, let's do the Canary play. Let's set this as a 50-50 split and do some refreshes on the browser and show how we're splitting this traffic between the two. So we'll go in. We'll switch this to 50-50. Write our config again. Switch back into console. Confirm that we are, in fact, 50-50 splitting. We'll hit this API tier. Now, because this was a new deployment, normally I would have spent the time to have the backend say, what database am I on, the Kubernetes one? It's just gonna be blank. So it's blank. Let's make this interesting. We'll go, what database am I on? We'll get kind of snarky. Oops, we'll go Kubernetes based one. Cool. Maybe. There we go. Because we're cloud native now. There we go. So what's happening is we're splitting the traffic, so it's hitting, like it's actually injecting into both of the databases. So unfortunately, like if the timing had been a little bit better there, it would have gone to the right one, but we're splitting between the two. So what happens is when I do that post, it fires off and actually posted into both databases. So now we have that entry in both, which kind of messes that up a little bit. So again, what we can do now is so it actually injected into the VM-based database and the Kubernetes one is still empty. But we can actually fix that and show how this can actually work the right way by going over and flipping everything into the Kubernetes data, or the Kubernetes based API tier instead. The Kubernetes API tier is coded to use the actual API tier inside of Kubernetes. So it is gonna be blank 100% of the time now. So we'll configure right. So now we failed all traffic over. And if we consistently refresh now, it's always going to be the blank one. So now we'll go, what database am I on? And we'll go the Kubernetes based one. I'll do a little self snark there. So we've now effectively migrated 2 levels of our API tier, or 2 levels of our application tier, from being front end on VM and API tier on VM to both being in Kubernetes to a database inside of Kubernetes at this point. I liked the dark mode personally more. So as I wrap up this demo, I'm going to flip the front end back and show how the front end can go back to running on VM while the API tier is still talking to the the front end is talking to the API tier inside of Kubernetes and the database inside of Kubernetes. So as we wrap up, we'll go in and do a Vim again on number 3. We'll switch this back so that our VM is running front and center. We'll drop that down to a 0. Should have just done it this way instead. We'll confirm in console that we flipped this back as we expected it to. Routing, everything back on VM. It's empty there, looking good. We'll refresh. We're back on dark mode. Wait for it to connect, awesome. And we're still running on the Kubernetes cluster. So we're wrapping up now. This is the rollout portion. You showed that what I've shown here is that we can easily take HCS and have it operate in a multi-platform model. It becomes this consistent service mesh and this consistent networking plane that lives inside of Azure, which is really interesting because when you think about real like enterprise environments, workloads are mixed. People are still using virtual machines for a lot of things. People are using Kubernetes for a growing amount of things. And being able to have a consistent networking plane between those that lets you split services between, shift traffic between those environments, do those migrations is something that people actually need. And you don't want to have to worry about the underlying infrastructure of Consul as part of that. We can manage that for you and let you actually get back to operating the environment, which is doing that traffic shifting and that migration. That's the work that matters. Standing up 5 Consul servers, 10 Consul servers, that's work that's important, but it's not the work that matters to delivering connectivity and applications. That's ultimately like one of the big things that I hope people take away about service mesh. It's not about being a catchy phrase. It's about solving a problem that we actually have. And that's how we wire applications together in this mixed platform world. And things like Consul Service Mesh does that. It does it really, really well. I want to highlight this on the screen right now. If you hit this with your QR scanner that John talked about earlier, I think we've used it a couple times now, this is going to dump you to a bunch of really useful resources. A lot of the Learn guides that our Learn team spends a ton of time working on and perfecting out to make sure that customers are actually able to come in and use our products. Check those out. It's really worth it. The new Service Mesh track is great. Spend some time in there learning how Service Mesh works. Check out the Layer 7 observability stuff. Check out the Kubernetes guides. It's really good stuff. Spend some time in there. A couple other things just to call out on this. I got the link for the Consul Kubernetes track. If you hit that QR scanner, you'll get all of this anyways, as well as some additional ones. These are just a couple I wanted to call out. Consul Helm chart. We have a great team focused on building this Helm chart inside. They're a great team to work with. Again, Irina's on the call. Make sure you hit her with questions. She's brilliant and is going to be able to help out a lot here. We have the Helm chart reference. This is going to take you through how to configure that Helm chart kind of end to end, all of the options that exist. We're going to talk, we have the Learn tracks here as well for the different tracks that matter, things like Kubernetes, as well as the Service Mesh specific one that is a newly revamped one. With that being said, thanks for the time. I appreciate you guys sitting through my presentation, and I'm going to hand this back over to Peter. Peter, take it away, buddy.